Episode 12, titled Run Change and Configuration Management Without Chaos, we set change and configuration management as the safety rails that keep reliability and security from tumbling when pressure mounts. Healthy teams do not fear change, they fear unmanaged change, because that is where outages, regressions, and security gaps hide. The goal here is practical and calm. Build a small, durable system that guides every modification from idea to verification with clear roles, recorded reasoning, and evidence that the environment ended safer than it began. When these rails exist and are used consistently, engineers move faster, leaders sleep better, and incidents shrink from cliff dives into controlled steps on solid ground. The language of change starts with categories that shape speed and scrutiny. Standard changes are pre-authorized, low-risk, and repeatable actions with proven steps and success records. They move quickly because the risk was paid down upfront. Normal changes are the everyday work of improving systems and require analysis, peer review, and planned execution. Emergency changes address urgent faults or exposures where waiting increases harm. They move under compressed approval but carry heavier logging and a mandatory follow-up review. Criteria must be written, specific, and tested against real examples so people do not negotiate classifications during a crisis. When category is obvious at a glance, the process is a helper, not a hurdle. Configuration management begins with a baseline that captures intent and a version control system that preserves history. A baseline is not a spreadsheet of toggles. It is an expression of desired state for operating systems, platforms, services, and applications written as code where possible so drift can be detected and corrected. Version control records more than diffs. It ties justifications, risk notes, and approvals to the exact configuration that shipped. Referencing tickets and commit messages links narrative to change, and tagging releases connects deployed states to auditable identifiers. When someone asks why a setting looks the way it does, you can show who changed it, when, and for what reason, rather than guess. Impact analysis is the hinge between intention and outcome, and it must cover security, availability, dependencies, and backout planning with realistic time estimates. Security analysis names the control surface affected, the authentication or authorization implications, and any new telemetry required to keep visibility intact. Availability analysis estimates user impact windows, performance effects, and failure modes if things go sideways. Dependency analysis maps upstream and downstream services, required credentials, feature flags, and data migrations so that success does not depend on lucky timing. Backout plans are written as specific steps with clear decision points and measured durations, not as vague promises to revert. When analysis is concrete, execution turns predictable. Separation of duties and approver roles prevent private bias from becoming public risk. The person proposing or implementing a change should not be the only approver, and self-approval is reserved strictly for documented standards with guardrails already in place. A peer reviewer examines the technical soundness and test coverage. A service owner or product owner confirms business timing and user impact. And a security reviewer evaluates control effects for meaningful shifts in exposure. The Change Advisory Board, spelled CAB on first mention, focuses on scheduling conflicts, resource readiness, and cross-service blast radius, not on rewriting design. Clear roles and no conflicts of interest rules make approvals an honest check, not a rubber stamp. Maintenance windows and communication plans remove the element of surprise, which is the main driver of unplanned downtime. Windows are selected with stakeholders to balance service-level promises and operational safety. They are published where customers and partners will actually see them, and they include start and end times that reflect real activity, not wishful thinking. Communication begins before the change, with a short, plain language notice, continues during the window with timely status updates, and ends after verification with a concise closure that states what changed and what users might notice. Internally, operations channels are primed with escalation paths and on-call contacts so help arrives fast if signals turn red. When communication is habitual, users forgive short pain because they feel informed and respected. Pre-change validation and post-change verification form the bookends of safe modification. Validation happens in a staging environment that mirrors production in the aspects that matter for the change being tested: configurations, data shapes, traffic patterns, and integration points. It includes automated tests, targeted exploratory checks, and, when relevant, security scanning aligned to the change surface. Verification happens in production immediately after deployment and uses monitoring, logs, and health checks to confirm that the system behaves as predicted. Success criteria are defined ahead of time so teams do not negotiate outcomes in the heat of the moment. If criteria fail, the team executes the backout plan and documents what the signal said and when they said it. Configuration drift is the slow leak that sinks reliability and security, so detection and correction must be continuous. Drift detectors compare live states to baseline declarations and raise precise differences, not vague, non-compliant labels. Policies protect critical settings from ad hoc edits, and automatic remediation resets simple deltas while opening tickets for complex or risky ones. Weekly reviews look for patterns, chronic drifts on certain services, repeated exceptions without expiry, or environments left behind during earlier migrations. The aim is not punishment, it is to close the feedback loop so desired state remains true state most of the time. When drift shrinks, incidents do too. Emergency changes deserve a special lane with higher visibility and tighter follow-through. Rapid approvals are captured in chat or ticket comments with names and times. Heightened logging records exactly what was changed and by whom. And post-change, a brief stability watch confirms that the immediate risk is contained. Within a fixed window, often 24 to 72 hours, the team completes an expedited after-action review that explains the trigger, the options considered, the chosen action, and any debt incurred. Debt might be tests to write, documentation to update, or a normal change to replace a temporary fix. Emergencies are not loopholes, they are compressed processes with stronger receipts. Metrics move the program from belief to learning. Change success rate shows how often deployments meet defined criteria without rollback or incident. Incidents per change exposes whether small batches lower blast radius, while mean time to restore tells you how quickly teams return to steady state when trouble does occur. Add leading indicators such as percentage of changes with predefined backout plans, percentage with staging validation artifacts attached, and time from deployment to completion of post-change verification. When a metric crosses a threshold, owners propose concrete adjustments, smaller batches, stricter review for certain surfaces, or additional automated tests. So numbers drive behavior, not just dashboards. Anti-patterns are common and fixable with resolve and small design choices. Undocumented hotfixes solve a momentary problem and hide a lasting one, so require that any direct production change opens a ticket and triggers a retro within a day. Shared administrator accounts erase accountability and complicate forensics, so replace them with unique identities, audited elevation, and time-bound access. Untested rollbacks turn "we can revert" into "we hope," so practice reversals in staging and measure how long they actually take. Each fix is dull by design and pays compound interest in calmer weekends and cleaner incident timelines. Boring is a virtue when reliability matters. Consider a scenario that walks a risky change through the full arc. A team proposes enabling a new cipher suite on a public gateway to remove weaker options. The category is normal because timing is negotiable and tests exist. The impact analysis notes security improvement, potential compatibility loss for a small cohort, and a 5-minute backout plan. Approvers include a peer engineer, the service owner, and a security reviewer. The CAB selects a low traffic window. Validation and staging runs active probes against supported clients and records negotiation transcripts. Pre-change communications notify customers who might be affected. During the window, the deployment commits the configuration, synthetic probes confirm only the intended suites negotiate, monitoring shows error rates unchanged, and user reports remain quiet. Post-change verification is saved with timestamps, and the record links all artifacts. If an old client fails, the backout re-enables the prior suite within minutes and logs the reversal, preserving both safety and learning. To put it all to use, create a lightweight change checklist for your next maintenance window and attach it to the calendar invite where the team will see it. Include plain prompts for category and criteria, impact notes across security and availability, named approvers and conflict checks, staging validation summary with links, pre-announced success and rollback signals, post-change verification steps with thresholds, and evidence locations for tickets, commits, and monitoring snapshots. Keep it to one page, insist it be completed before the window opens, and review it briefly in the first stand-up after the window closes. When the checklist lives where work happens and speaks your team's language, chaos yields to rhythm, and rhythm produces reliability. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.